welcome. Alright, a video or two back, maybe 2 videos back, I talked about how I don't have an oven, so I can't make blades. So in the meantime, I've come up with another project, and they're called tweezers. So, I know you know what tweezers are, but here is where I'm currently at with the tweezers. Yes, they're literally tweezers. See? Aren't they so cool? So, yeah, that's my tweezers. I might change this back area a little bit, but what we're going to go over today is the thing that I don't know if I can do, but we're going to try. This is a 3D printed cap for them. So I was like, okay, I like this tweezer. I kind of like the size. It seems to work pretty good. But there's one problem with it that needs to be addressed. You can't put it into things without the jaws wanting to scrape or cut things. They're very sharp. Like, I made them sharp on purpose because, you know, tweezers. So what I was thinking was, if I made a cap for it, then I could remove the keyring hole. So this is a 1/8 hole, basically, and it goes on like, you know, like keys, like that. So what I decided was, if I could remove that, then I could use the back area for maybe like a prying section, or like right now it's sized for a screwdriver, a flathead, which I think is pretty cool. But then I can move the keyring hole to the cap. So basically the way it's going to work is like it snaps in, and the way I want it to work is you can snap it in with one hand and pull it out with one hand. So you don't need to like press it. Well, of course it's one hand. What I'm saying is you don't need to press it to get it into its cap, basically. So that's why this geometry on here is kind of weird. Like a duck, kind of. Looks like a duck. Quack. So, anyways, it goes in like this, it snaps in, and then you can pull it like that, and it's easy, and it needs to be strong enough to basically be, well, I don't know, flailed? Tossed around so it doesn't come off your key ring no matter what you're doing, no matter what crazy activities you find yourself getting into. Yeah, there is a hole in the titanium tweezer market, I assure you. There's plenty of pry bars out there, but there are not enough tweezers, so that is what we're doing. Anyways, what we're doing is we're actually going to make the cap. I'm going to try to make this cap on the lathe. So I've designed it in a way that I can use the live tools to cut the front pocket and the side pockets. And I just spent a long time programming on Fusion, a preliminary program, if you will, so we'll go over that. But yeah, so we're gonna do lathe work, I guess. Whatever. Alright, here we are. Here is the cap. It is very tiny. It's hard to describe how tiny it is, but this is a 16C, call it for reference, so yeah. Alright, so in our main setup, the normalness, we have it set up as a spun profile. So we're gonna do this interesting face where it comes down to the center and then retracts, still touching the part. That should give us a really nice finish. Then we're gonna drill a clearance hole or a pilot hole for our 1/8 cutter to go into the pocket, like so. So there's this down pocket, it's got to go, and then there's this upper pocket, but it's going to do the upper pocket first, and then it'll do the down pocket, so that'll give us a little bit of chip clearing evacuation type geometry. Then it's just going to contour finish both those pockets. Then we're going to rough out most of the side. Then we're going to use a 5/64 end mill, I think is the size, to do the actual pockets on the side. The pockets on the side right here are where the tweezers snap into, so they snap into these side pockets. Pretty self-explanatory. So the cool thing is it's orientated in a way you can't fit the tweezers in this way. It only goes in up and down, so it's you can do it in the dark. Fantastic. Yeah, so that's that. Then I've been using patterns a lot lately, and they're very helpful. So we're going to adaptive the edges here as you can see, like I said, I made it with the intention of making it on the lathe. So this is cut out of a round profile. So we're going to adaptive that, and then we're going to contour. Then I have it patterned. So basically the way a pattern works is you can pattern it, and I just use some construction planes, which are right here. This is not that important, but if you don't know, you can do this. So like here's a mid plane, so it's patterned against this mid plane to give us this two, and then what I did was patterned the pattern mirrored on that other mid plane that's this way. So what you're left with is actually 4 tool paths, actually 8 tool paths. So it's going to adaptive, and the reason they have a little bit of separation is because I'm not going center to center, I'm doing a little bit of an overlap, and I think that will make the end mill a little bit happier. I don't know. Then we're going to come in and do the keyway, or the key ring, excuse me, with a adaptive. And the cool thing about adaptive is you can go and do this thing called a ramp taper angle, and you can actually set the ramp to taper in like this. So you notice that this ramp has a taper, it's a funnel. So that's cool, that's what I'm doing. I might end up changing it to just start ramping down here. Obviously this material is not here, but this is a prototype, if you will. Then we're going to finish the outside profile with a VNMG 331, a very tiny radius tool. And then this is where things get a little weird. So I'm going to try to sub-transfer this while they're synchronized and spinning, and part it off while it's synchronized and spinning. And I have not done that. And I'm going to have to get the other parting blade out, and I'm not sure how well this is going to work, but we will see. See, I'm looking here, and I know the subspindle jaws are pretty tall. They're like here. And I want to grab on like here, so you can already see we're going to hit our parting blade. Or I have a grooving tool in there right now, which, you know, you can use a parting blade. But we will check that out after we get through this very long first live tool-ish process. Then, after all that, it's in the sub. Imagine it's already sitting in the sub, and what's left is we're going to face, and then we're going to smooth up that area, and then we're going to, this is kind of hard to visualize, but it's going to do this, and just clean up that final face. And what we'll be left with is actually this. It's kind of an interrupted cut. Terrible for the cutter, but that's just how it's going to be. We'll be left with, hopefully, a done part, and it'll drop in the sub spindle, the sub catcher, and we will make millions of dollars, and I can finally buy that Tesla I've always wanted. Probably not going to happen. Alright, back to the real world. It's been a couple days. I think it'd be nice to be able to transfer and finish the back face of these caps. So I'm over here trying to figure out our clearances. As you can see, this machine doesn't like to do small parts. I can't imagine why. So I'm thinking, so here's the issue. So you got this gap between here and the front jaws of the subspindle is basically 1 3/4 inches, and when you think about the stick out of the part by the time you get down to the final dimension, it's like a really far stick out for this. So I'm thinking, if you can shorten the distance, obviously that gives you a lot better surface finish and tool life, and it's just better long term. So the biggest issue right now is the subspindle jaw can contact this block. See this? That's what's stopping us from going any farther forward. So what I'm thinking is I'm going to take the part off blade tool holder and I'm going to lop this corner off and get that out of our way. So yeah, that's my current plan. Because if I could stick the jaws basically this distance closer, I mean, I gain almost an entire inch, and that would really alleviate a lot of problems, I think. See, my part off holder is kind of big, and it's also a 3/4 holder. It's not a full inch, so I have to use this shim right here to get it to work. But I think if I could lop this off and stick this a bunch out, and then stick this a bunch out, we would have enough like a tight enough area to work with. So I'm probably going to take that out and burn it on the mill. But I think this might work, but I'm not too sure. Guess we'll find out. Little intermission. I'm tapping a 8th NPT into this live tool holder because it only has a nozzle and the end mill's over here and the nozzle can't reach the tip of the end mill. So yeah, this is what I'm going to do. I'm going to do this and then I'm going to install a lock line so we can actually face the coolant towards our end mill, because deep in that pocket there's no way to get the chips evacuated properly without the coolant being aimed right at the tip of the end mill. So that's what I'm doing. Good times. Alright, ladies and gentlemen, let's talk cam. So here is our cap. It's been a couple days, so I changed a couple things, but yeah, so anyways, I have run one of these not complete, but I do know that all the milling works, so that's a really good sign. So basically, we have our main spindle, obviously. First we're going to face, and then do that face thing where it basically retracts touching the part, gives us a nice surface finish. We're going to drill a clearance hole in the center of our tweezer pocket, if you will. And that's just number 45 drill, I guess. Or number 30 drill, sorry. Then we're going to come in and do a pocket, and the pocket is going to do... It's with a 1/8 end mill with a corner rad. So first, what we're going to do is we're going to actually pocket this top pocket, and that'll give us some chip evacuation type hole for the second pocket. I think you get what I'm talking about. So it's going to do this first one, and then it's going to go down and do the bottom one. And I basically have a finishing pass just built in there instead of doing a contour, because that eliminates the retract, and the C-axis on the lathe is a little weird about making really small moves. Obviously the C-axis is like synchronized with the X and Z, and so if the C-axis can't make it to the position in time as fast as like X or Z can, it'll actually alarm the entire machine. So I found that doing it this way causes that not to happen. So pocket, and then after that we're going to rough the outside. So we're actually going to go back to tool 1 up here, and the reason I didn't rough this first is to keep the some rigidity in the stock. Might not be necessary. It is a small pocket with a small tool. Then a chamfer, so we're just going to put a fat chamfer on the end that's going to be adjusted. Also, I wanted to talk about, there's no chamfers on these ledges in here. So I may end up doing something with those, like right here and here. The nice thing about using a corner radius end mill is you can use the corner radius to actually make, you know, sort of like wannabe chamfers or fillets. Then we have a pattern, and it's a 2D contour, and that's how I get the side pocket. So we're going to radial mill this with a 5/64 end mill. So originally what I was doing was I was trying to mill these pockets without using wrap toolpath like this. Oh, okay, well I had it. When you have wrap toolpath, you can't use tool orientation. So basically I would use tool orientation and stick the Z like center here and do like a normal contour. Well, the C-axis doesn't put the right code out to actually mill the pocket, so you have to use this wrap feature, which is pretty cool, and I messed this up somehow. Right, so what you do is you just select the contour. Oh, that's why. You select the contour, and then the cylinder you want to wrap, which is this thing, and then you hit OK, and it'll actually generate proper code for the C-axis. So the thing with the C-axis is the radial tool always starts, is always the center of the part, so you have to have the code that's output needs to basically be aware that you can't have anything that's off center, and that's what it was doing before. So you can see that it starts center and then eventually it leaves center, and it's basically going to interpolate this contour for us. And I have it patterned, so we do both sides. I have proven this works. I did this yesterday, so that's good. Then we have the keyhole, or the for the key ring. Now this one's a little interesting. Notice the pocket almost folds into like some sort of weird looking burrito. Well, when it gets to the bottom here, it starts to make the lines of code. It starts to add a lot of digits to the end of like this a C-axis or X-axis move, so it'll be like a 5-digit move as opposed to, you know, just like a tenth or whatever. So what's been happening is the FANUC controller's been erroring out and saying too many digits. So that was the last I had on the last time I tried this. So we're going to try this now, and hopefully it doesn't do that, but I'm sure there's a workaround. Then after that, we're going to rough out this section. I'm still working on this area, then obviously finish it, and we're going to stop. I'm not going to part it because I plan on transferring it synchronized and parting, so that'll be interesting. But that's where we're at. So it's very funny because the program's huge because of all the, I mean, huge. It's huge in 2004 memory sizes and memory size, so it's pretty funny because it takes absolutely forever for it to load into memory, like a good 3 minutes to load one of these programs. And, you know, 2D Pocket's not exactly a hard-hitting program. So let's see, like I said, we're going to go all the way up to the point before we part, and then I need to figure out how to do all the sub-transfer stuff, so it's going to take me a couple hours, but this is where we're at so far. So your typical face. Put a nice surface on there, and then we can drill for a clearance hole. Definitely hard to see what's going on, but I assure you there's a... oh, there it is. Cool, and that gives us our clearance hole. So then we're going to come in with the axial tool, which is the thing I just put the coolant nozzle on. Camera is having a very hard time focusing. So yeah, you can see the C-axis has to move quite quick to keep up with the X and Z movements. So that's why it'll error out, I guess. Cool, here is the latest tweezer. See, I removed the circle on the back. Made it a nice Phillips 2, I think, or a flathead 2. And that way, these caps, that's now your key ring holder. So here's the hole. Fits good. It's obviously missing the side part, so yeah. So that's what it's supposed to do. Like I said, I want to do a one-hand operation, so you don't need to worry about like closing them to take the tweezer out. Okay, so next we're going to do the outside roughing, and that'll take us down pretty close to final diameter, and then we'll do the contour, that wrap toolpath milling on the ends or on the sides. I think you guys kind of understand what's going on here. It's just roughing out, so. Interesting enough, I left a nice bird's nest, so that's definitely something you gotta keep in mind, because what's gonna happen is this very small tool is gonna come in, this guy, and my guess is if it grabs this nice bird's nest, this is 17.4, it's not titanium yet, but this stuff's pretty strong, so I would guess it could break the end mill, but I'll have to figure out something else for this, but not that great. So you can see we have the roughed out profile. This isn't hardened stainless, it's just annealed, so finish wise it's actually pretty good. There's a front chamfer. Cameras don't like shiny things, I guess, so you can kind of see it. So now it's going to do that contour with that radial tool, which I think is actually really, really cool. But I'm biased. So that's what wrap toolpath does. Pretty neat, right? Now if you had a y-axis, you could do non-wrap toolpaths, but since this doesn't have a y-axis, everything has to start from center and be interpolated like that. I guess that's the word. But yeah, that's why having a y-axis is pretty sweet, because you can do quite a few things, but work with what you got. So just finish the first one, then it does a 180 and it'll do the second one. And looking at the movement, you can see it's kind of going crazy, but this is what it's doing as it goes down. So you can see all those movements are synchronized. Now this might not work, so it's going to do the key one now. And this one, unfortunately what happens is it gets lower and lower in the hole. The C-axis has to move faster. I think anyways. And the numbers in the program, I guess, start to become really big. See how many digits there are? And I guess that causes the control to error out. It doesn't like having a bunch of digits. Yeah, see, there you go. Excellent. So I kind of need to have those holes, so I'm going to work on the fix for that and get back to you guys, but that is live milling, or radial milling on here. Works pretty good, actually. Okay, so I worked on this problem for like the last 2.5 hours, but I finally got it working. So what I ended up doing was going in the post processor and changing the available decimal units it could use to just 3 as opposed to 4 when it was in inches mode. So that basically gave me enough room to have it not error out. So yeah, perfection. Science. That was close. Alright, so we finally got the pockets done correctly. Now it's going to rough or shape, which I don't think this is going to work that good, but I'm not too sure. So basically it's going to take this nice fine radius or reliefed cutter and basically cut down into the corner. Well, that sounds healthy. Yeah, so that was chatter. That's awesome. Yeah, it needs a little work. Aren't lathes cool? Should be a finishing pass, which will probably shatter. Oh yeah. Oh, sing the song of my people. Crunchy. Oh god, there's a finishing pass again. What do you call it? A spring pass, yeah. Forgot I left that in there. I'm sure that's good for the cutter. Alright, well that's what we got so far. This is the most complete one I've seen. Isn't that pretty? So now we need to figure out how to transfer and part off synchronized. That should be interesting, but I'm gonna leave you guys here. Alright, well, that's the end of that part, this first part. The getting it to transfer is probably going to be like another couple hours, so I don't want to record all that and then mash it in one big video because like other people, I don't have the attention span to watch longer than like 10-15 minutes, and most people don't, so try to make it a little bit shorter. But anyways, yeah, so if you want to buy some tweezers when they come out, I'll post them on Instagram, but I'm sure they'll be on the website at some point. I need to sell something, otherwise I'm going to starve, but till then, or till the next one, have a good one.